let's see. Here's how I would see the challenges for quantum computing moving forward. There are the hardware challenges. There's benchmarking, error correction, fault tolerance, and then there's algorithms. And of course, there's a lot of we can't get started until we have the hardware. But if we get the hardware and we don't have algorithms, the whole enterprise sort of falls off a cliff as well. So all these are extremely important aspects. And in order to get to all of these, we really have to have a more more of a dialogue between computer scientists and physicists, mathematicians, and so on. And in the early days of quantum computing, I would say that there were probably more computer scientists than physicists in the field. That gradually became equal. But starting 20 years ago, the number of physicists dramatically increased, but the number of computer scientists did not. And there are a couple of major reasons for it. When you're sitting inside computer science, quantum computing seems so distant. It seems like science fiction. How do you know it's true? It's something very different. And there's a major barrier to entry, which is quantum mechanics. Right? So it's much easier for physicists once they put their minds to it to say, yes, okay, it's real. We find it interesting now. Switching is not so hard. And from a computer science point of view, this barrier to entry is really, really high. So this was a question that we all thought about a lot, and to me it seemed like there was the Simons Institute at Berkeley provides a really interesting environment to address some of these challenges and to sandbox possible strategies. And so that's what I'll speak about for a little bit. And then, if there's time, I'll also talk about how through the CIQC, the Challenge Institute, the NSF Challenge Institute at Berkeley, we are looking also at strategies for master's programs, etc. More concrete things. So, okay. So what's the Simons Institute about? Well, it's an institute that brings people together for semester-long programs, etc., to explore the nature and limits of computation, and where computation is defined rather broadly, in terms of computing as a lens. So you look at it as reaching out to the natural, social sciences, engineering, physical sciences, etc., mathematics, and it has various structures for convening people. The principal structure is through research programs that happen every semester, and every semester there are two programs, and it brings together roughly, each program brings together roughly 30 senior visitors, scientists, to stay there as residents, something like 8 to 10 postdoctoral fellows, and students, etc. And then each semester there's a boot camp to get people up to speed in that field, and 3 workshops. There are also now summer clusters, smaller such programs. And the thing that we've created now to as a way to deal with the issues that I spoke about is these research pods, one of which is in quantum computing. So the idea is this, so there's this barrier to entry, and one way that you can get the larger community to step over this barrier is by realizing that it's very hard to read papers in a subject, or in your own subject, but certainly if you're crossing disciplinary boundaries, the barrier becomes extremely high. It's much easier to have a colleague who says, there's this interesting question, so you're talking about something, you find an interesting question, and then each of you is responsible for carrying their own part. You're looking at it from one viewpoint, the other person's from another, and you can have a collaboration where one person is quantum savvy and the other person is not, and this is in a sense a way of teleporting straight into the research, understanding what's going on, and then once you start understanding in the context of a question that you really are working on, it's easier then to fill in all the rest. Okay, so for our colleagues who are already researchers who are working in computer science in some other area, it's so much easier to teleport in this way. Also, okay, so now, okay, so the other thing about this, about the Simons Institute, it's the physical and space is designed for collaboration. So there are whiteboards everywhere. It's really a great place to do this. So let me just show you about the mechanics of this pod. So currently we have something like 9 or 10 postdocs in and a small handful of visiting scientists who are there. They're in the long term. So the idea is that these people not only interact with each other, they interact with the NSF center, and there's a DOE center, both of which actually sponsor this pod. But then in addition to all this, this is sort of a setting which is fantastic for postdocs, because not only do they get to interact with each other and with these quantum centers, but they also get to interact with these semester-long programs, which have their boot camps and workshops and these incredible visitors. And so this is an incredibly stimulating space for them to be mentored in, and for them to actually draw other people into this research program. Of course, it also helps that there's a daily tea where everybody gets together, and those are always great things. Now, one of the things that we did is we launched a colloquium early this year, and this served a very important purpose. So we had people who came through, experts in quantum computing, who would say, I'm losing track of what's happening in the field. Between things are happening so fast, it's hard to keep up with papers. It's also hard to keep up with the hype, because it's hard to even figure out what's true and what's not true. And so the colloquium was supposed to make the field accessible to experts, parts of the quantum computing community. And it turned out that having not just the colloquium, but also panel discussions afterwards, this was during the on Zoom because of COVID, and it really did create quite a sense of community among the researchers. This fall, the colloquium ended up being more about bridging between experiments and theory. In the spring, the coming spring, I think the focus, I'll try to make it more about bridging between CS and quantum to bring more quantum computing people into the okay. And in terms of activities, we've had these semester-long program which was co-located with lattice cryptography. We've had summer clusters this last summer in person, and we'll have another one next summer where we again co-locate with lattice cryptography, and this really created quite a interesting give and take between the two fields. Okay, so I guess I'm going to, since my time's up, I'm going to skip the other part of the presentation where I was going to talk about master's programs and so on, because this is maybe more what I wanted to talk about. Thank you.